Hi, hello everyone. I hope you guys are doing well. Myself, CHAVADIHINDALA from GM Institute of Technology. Today, I am here to present about the our project phase one presentation, batch number 18. Our problem statement is pneumonia detection using machine learning and neural network model. Our teammates are Darshan DV, Chetan Kumar SH. Our project guide is Paveshri PN, Assistant Professor at GM Institute of Technology. Project coordinator Mr. KOTRESH SN is also Assistant Professor from GM Institute of Technology, Head of the Department of CSE, Dr. Shivan Goda GM. Without further wasting your time, let's move on to our actual concepts. The contents the contents involve the introduction, problem statement, algorithm design, correctness and validation, results and references. These are the 6 steps which are involved in this presentation. Let's move on to the introduction part. The introduction. Pneumonia is lung infection that can be life-threatening if not detected early. Uh, detecting the if you are not earlier detecting the pneumonia, it will affect the human life. Traditional diagnosis relies on X-rays and medical expertise. Um, Deep learning, especially, we are using convolutional neural network model, commonly known as CNN model. Our goal is to build the CNN-based model to classify the sex images as a normal and pneumonia, in which we are using huge amount of data involved the two types. One thing is normal conditioned X-rays, and other one is pneumonia detected X-rays. Problem statements, as I said earlier, pneumonia detection using convolutional neural network, CNN, and deep learning model, algorithm design, and well structured, logical, and documented step. First thing is data acquisition. Before we are training any large language model or deep learning model, we require huge amount of data. So that data acquisition plays a very vital role in the DL model building. Where we are acquiring the data chest X-ray, which involve the normal chest X-rays and pneumonia detected chest X-rays. Data split. We are splitting the data into three types. One thing is training for 70% of overall data. Validation, we are using 50% of our data for the validation of our model. For testing the model, we require 50% of data. Second one is pre-processing. Pre-processing involving the resizing the images to uniform size. In general condition, our X-rays are not in accurate sizes. So maybe 225, 220 into 224 width and length. To convert that data into formal size, we require pre-processing. Normal pixel values are 0 and 1. For black and white images, X-ray images required have only 0 and 1 binary values. To apply the data augmentation, uh, we are rotating the X-rays, flipping the X-rays, and zooming the X-rays for robustness, handling the corrupted missing files gracefully. Next, moving to the next thing, CNN model architecture. Here is our core model architecture lies. CNN model containing input layer, convolutional layer, relay activation function layer, pooling layer, dropout layer, and fully connected layers, and softmax output layer. The softmax output layer is the end or the last layer in the CNN model. Input layer contain for input layer just X-ray images array as a as act as a input for the input layer. Convolutional layer main function is extract the special special features like edges, textures, and patterns. Relay activation functions. The relay activation function is a non-linear activation function. It is a mathematical function. Pooling layer. Pooling layer is a we are using max pooling here. Reduce the dimensionality. Reduce the dimensionality means um, the chest X-ray images when it goes to input, middle what hidden layers, it is having the high dimension. To convert the high dimension into low dimension, that will the real what pooling layers will convert that high dimensional data into low dimension data like this. And the dropout layer helps to prevent the overfitting. Fully connected layers learn high level patterns. The fully connected layer helps to learn the higher level of patterns. Softmax function is a um, fast output function layer, which is classified as a normal and mnemonic. It will help to classify the uh, different type, like two types. One is normal, and the other one is uh, pneumonia detected images. Next, moving to training process. Training process having the loss function, cross entropy, optimizer, batch training with mini batches. It will batches the overall images into 32 images epochs. In our model, there are 25 epochs. Epochs means how many times each one of the images will go through the overall model. Efficiency and considerations. CNN reduces the manual feature. What is the main difference between what? What is the main difference between DL and ML means? Say in case of the in case of the in case of the ML, the if feature extraction is should be done by the programmer. In the CNN model like DL deep learning model, it don't require a feature extraction. Feature extraction like uh, feature extraction is done by manually. It's not manually in the DL model. Um, efficiency and efficiency consideration. That's what I explained already. Pooling layer minimizes the memory consumption. So pooling layer means that pooling means it will reduce just the dimensions of high dimension images into lower dimensions. Dropout regulation, balance uh, accuracy and dropout regularization. Next, moving to the edge case handling, noise or low quality X-rays improved with the pre-processing. Through the pre-processing, through the pre-processing, through the pre-processing, loss function, binary cross entropy. Oh, it's not coming. Okay, edge handling, noisy or low quality X-rays improved with the pre-processing, class imbalancing handled using data augmentation and weight loss. Variable patient ages like say let's deep dive into this concept like see some of the ages are maybe varies like 16 or 68 like that of ages, different varieties of ages of x-rays are there. To to convert that data into different type of angles, CNN generalizes well with the augmentation. Data augmentation will help. Next, moving to the next slide. Here you can see Here you can see the actual. I think it's not loaded yet. Okay, yes, you can see the convolutional neural network. Here is the zebra image as a input layer, the kernel version, and which means that it will cut the images into number of parts that will goes to um, inner layer in the convolutional layer, which are only convolution plus ReLU function, convolutional plus ReLU function, which are all act as a cooling functions. Cooling means it will reduce the high dimension data into low dimensions and flatten layers. I think it's not visible to you. Okay, we'll go you. Fully, this is there are three types of in CNN. We can see here fully extraction, classification, and Probabilistic distribution, it will the probabilistic distribution softmax activation function will check that, and it will compare with other thing, and it will say at the end of the time, it will say that what is horse or zebra or dog. That will predict it is zebra. That is the convolutional layer architecture. Here is the convolutional layer architecture. And let's move to the next slide. Efficiency in terms of time and space. Hmm. Time efficiency. CNN automatically automates the feature extraction. Main helpful feature from the CNN is it will extract the each features from the images, like bone bone tilting, like cell fractures. It will reduce the pre-processing time. The convolutional plus pooling layers, which means that the convolutional plus pooling layers few computations versus fully connected networks. Mini batch training plus GPU acceleration. With the using of high level GPUs like NVIDIA's 5040 and H100, A100 GPUs, we can step up the performance of the our model. Real time efficiency 1 second per X-ray GPU. Let's move into the next slide. Space and space efficiency. Weight sharing in a convolutional kernels. Few patterns to store. Pooling layers shrinks features maps. Lower memory requirement. Dropout reduces the redundancy. So redundancy means repeating images, repeating X-ray images. Training space. Model size is compact. Um, so so it will not rely on the what memory. Instead of that, the memory is very less, deployable on cloud or mobile devices. It's really very helpful for the we can deploy our model into mobile and cloud also. That's the main features of our project. And moving to next slide. Correctness and validation. There is comes correctness and validation. I think it's not loaded yet. Okay. Correctness and validation. A model trained and tested on a chest X-ray dataset, in which we are training the model both the things. Normal, we are training the model with a normal X-ray and pneumonia detected X-ray also. We are achieving the accuracy. Uh, Here we are written 90, but actually our model is around 73% of accuracy we have seen. Handled both normal and pneumonia cases effectively. Performed proven with a confusion matrix and ROC curve. The references, the references from the references are the machine learning and machine learning, Dr. Vijayalakshmi and Sridharam textbook, which is a very which is helpful for very which is helpful to me to understand how actually CNN is work. Deep learning textbook from Ian Goodfellow, identifying the medical diagnosis and testable diseases, treatable diseases by the image based deep learning. Chest XNet, radiologist level pneumonia detection and chest X-ray with the deep learning. Mm. Radiologist level pneumonia detection on chest X-rays with the deep learning. And here, thank you everyone. If you have any um, like queries, please put a comment on this video. Okay, thank you everyone. Thank you everyone.